So here in example 1, we want to represent the following integral as the limit of a Riemann sum. And note we're going to use right-hand Riemann sums. So that area is going to be the limit as n approaches infinity of the sum from k equals 1 to n. So it's going to be area equals the limit as n approaches infinity, sum from k equals 1 to n. That will never change. Now I need to figure out f of x sub k multiplied by delta x. Well, the first thing I'm going to find is delta x. That's b minus a over n, which is 4 over n. And x sub k, oops, make my x bigger, k smaller, is a plus k times delta x. Well, a in this case is 2 plus k times delta x. So now I'm going to plug this into my function, which is x squared. So it's going to be squared, but instead it's going to be 2 plus 4 over n k. And then multiplied by delta x multiplied by 4 over n. So that would be the limit definition for the net signed area under the curve. So now part B, same idea. First I need to find delta x. Delta x is b minus a over n, which is 5 over n. And x sub k, if I'm using right-hand endpoints, it's going to be negative 1 plus 5 over nk. So now I need to write this as a limit. Area equals the limit as n approaches infinity, sum from k equals 1 to n. Now I need to take this x value and plug it in for this one in this equation. So it's going to be square root 2 plus negative 1 is 1 plus 5 over nk. And this is all going to be multiplied by the base of each of my rectangles, 5 over n. Oops. So that is the limit definition for the area under a curve.